Okay, today we're looking at section 5.1 and we're looking at how do you simplify expressions with exponents. So we're going to study properties of exponents in this section. Okay, so some of it should be review, however we're extending it a little bit. So for example, if I had 2 cubed and I want to multiply it by 2 to the 5th, 2 cubed could be written as 2 times 2 times 2. 2 to the 5th is 5 2's. So the way this could be written is then 2 to what power? Well, we have how many 2's there? We have 8. So what would have been the shortcut for simplifying this down? It would just be to add the exponents. Okay, so that's one of the properties of exponents, the product of powers property. Okay, and we have several other properties we're going to look at so we can simplify problems like these ones here. Okay, so in your book on page 330 are all the properties. I'm going to pull my book out right here. This is page 330, key concept. And we're going to go through each one of these. So the product of powers is the one we just showed you. If I have the same base, okay, so the same number on the bottom there, in this case it's a variable a, all we do is add the exponents. So their example there, 5 cubed times 5 to the negative 1 power, we just add those exponents to get 5 squared. Power to a power property. So now I have a power like a to the m to the n power. We multiply the exponents. Okay, in this case, you have 3 cubed to the second power. You multiply the 3 times the 2 and you get 3 to the 6. And that one you can think about as 3 cubed is 3, well, let me write in my book here, 3 times 3 times 3. Okay, and if I'm squaring it, I have 2 groups of those. So how many 3's do I have? I have 6 total, so that's where that kind of makes sense there. Okay, power of a product property. Okay, if I have a product of 2 numbers and I'm taking them both to the power, I can take each item individually and take it to that power. So 2 times 3 to the 4th is the same as 2 to the 4th times 3 to the 4th. Negative exponent. When we simplify, we want to eliminate negative exponents. Okay, a negative exponent can be simplified by just changing the location of it within a fraction. Okay, so a to a negative exponent is the same as 1 over a to that positive exponent. Okay, so for example, 7 to the negative 2 is the same as 1 over 7 to the positive 2, or 1 over 49. Okay. Now it doesn't show you, but if I have a negative exponent in the denominator, I can bring that term up to the numerator and change it to a positive exponent. So if I had 1 over 2 to the negative 3 power would be the same as 2 to the positive 3 over 1, or just 2 to the 3rd. Zero exponent. Anything to the 0 power is equal to 1. Okay, so that one's pretty simple. Anything to the 0 power equals 1. And we'll look into proving some of these in class. Quotient of powers, a to the m over a to the n, we subtract the exponents, a to the m minus n. So in this example here, 6 to the minus 3 over 6 to the minus 6, we subtract negative 3 minus negative 6, which becomes 6 cubed. And then finally, the power of a quotient, a over b to the m, we just take the numerator and denominator to the same power. Okay, so 4 over 7 squared is 4 squared over 7 squared. And if you can square those values in your head, you can do it. Go ahead and do that. Okay, so let's look at this example 1 real fast. We have negative 4 times 2 to the 5th squared. Okay, so we're going to use the power of a product property because we have a product and we're taking it to a power. So we take that squared power and attach it to both items on the inside there, and then we're going to do the power of a power property here and multiply 5 times 2 and get 2 to the 10. So you get 16 times 2 to the 10 because they squared that one. Okay. Now you could leave it there. If you have a calculator, you can calculate it out. Okay, part B, we have a negative they're using the negative exponent property first. So you can see there's a couple ways you could do this one, but when we multiply this in there, we get 11 to the negative 5 and 11 to the negative 8. They're flipping it and making it positive because of the negative exponent property. And then they're using the quotient of powers property then and subtracting the exponents and get 11 cubed. Okay, so that's kind of an example of a couple of those properties. So let's go back and look at these examples here. What you may want to do is try these on your own, see what you get, and then we'll work through each one. So pause the video, give them a try, and then we'll go through each one. Okay, so this first one, 4 squared cubed, is going to be the power of a power property. So what do we do with these? We're going to multiply them. Okay, so it's going to be 4 to the 6th. Okay, now do we have to calculate that? Well, if you have a calculator handy, you can figure that out on your calculator. Otherwise, we'll just leave it as an exponent like that. Number 2, negative 8 times negative 8 cubed. This is a product of powers. What's the power on this first one? The power is actually 1. Okay, so what we can do then is we can just add the exponents and get negative 8 to the 4th power. Again, if we have a calculator, we could calculate that out. Okay. Number 3, power of a quotient. We have a quotient to a power, so we take the numerator to that power and the denominator to that power. Now this, I know what that is. That's 8. 9 cubed. I'm just going to leave it as 9 cubed. Calculator, you could calculate that out. It's actually 729, so you could actually write 8 over 729. Okay, so each of these, we're applying these properties to actual numbers, and we're just simplifying it down. The more useful part of it is when we apply it to variables, okay, when the base is a variable, okay, because we're trying to simplify down the expression. Okay, so this one, number 4 then, we have a power of a power, or a product of powers, so we're going to add those 3 variables. So we get x to the negative 4, x to the 6, x to the 7. We just add those up. Let's see, we get 13 minus 4, so you get x to the 9 on that one. Okay, this one they're going to get a little more complicated. This one we have a product of powers. So we are going to bring this squared in to each one of those terms in there. So we got x to the minus 3 squared, x or y to the 3 squared, and then x5, y6. Now we have a power to a power, so we multiply those. Okay. Now we have a quotient of power, so we can subtract those. So we got to be a little bit careful. So we go negative 6 minus 5 is x to the negative 11. And then 6 minus 6 is 0. Okay, so now anything to the 0 power is 1. So that's the zero exponent property. So that's just going to be 1. So then we get x to the negative 11, which we can make positive by putting it in the numerator, or in the denominator, in the bottom. Okay, so this whole thing simplifies to 1 over x to the 11. Now you might have approached this differently and still got the same result. Okay, let's look at number 6. Okay, we have a power to a power, so we have to square everything inside of here. So let's see if we can do it without actually writing the steps. 7 squared is 49. Y squared squared is y to the 4, because we got to multiply, and then z to the 5 times 2 is 10. Now we're multiplying it by this one. So what do we have to do with our common exponents? We have to add them. So we get 49 y to the negative 4, and then z to the positive 8. Then we eliminate the negative exponent by putting it in the denominator. So we leave the 49 on the top because that doesn't have a negative exponent. Its exponent is 1. We leave the z to the 8th in the numerator, and we put y to the positive 4 in the denominator. Okay. Number 7. So we have to square everything. So we get x to the 6 over y to the negative 8. We have a negative exponent here, so we move it up. And so it's going to be x to the 6, y to the 8. Notice this one stays put because it's a positive exponent. Okay, and finally number 8, we're cubing everything inside of here. So there's a couple ways you could approach this one. We could simplify within and then cube, or we could cube everything and then simplify. So I'm just going to cube everything first and see what happens. So we have to multiply, so 12 y to the negative 6 over x to the 9 y to the 18. Okay, so now we subtract. Now again, here's another way to approach this. We can subtract these. 12 minus 9 is x to the 3. And we could actually take this, and we know this is going to have to go in the denominator. So we could write that as y to the 6th down here. And then we could add those and get y to the 24. Or we could have just subtracted them. Negative 6 minus 18 is negative 24, and then we move it down to the denominator and make it y to the 24. So you can see there's a few ways to approach these. Okay, so there's some examples. Now the other thing in this section, they talk about scientific notation a little bit. So I'm going to just show you a couple things on scientific notation. A scientific notation number looks like this. C is some number that's between 1 and 10 times 10 to a power. So it could be, an example would be 4.3 times 10 to the third would be a scientific number. Okay, now if I wrote that as an actual decimal number, this exponent tells me how many places to move the decimal to the right. So if it's 10 to the third, I move it 3 spots to the right, so this would be 4, 3, so it would be 1, 2, 3, so I'd have to add 2 zeros. And this number is actually 4,300, because 10 cubed is really 10 times 10 times 10, which is 1,000, 3 zeros. So 1,000 times 4.3 is 4,300. Okay, so the simple thing is to just move the decimal to the right 3 places. If it is a negative exponent, let's say it was 4.3 times 10 to the negative third, then we move the decimal 3 spaces to the left. So it would be 1, 2, 3. So we'd add the 2 zeros there, and it would be 0.0043. Okay, so now what they're going to do in this section is they want you to multiply 2 scientific numbers together. So in order to do that, the order of multiplication doesn't matter. So we can multiply the numbers together first, 8 times 3, which is 24, and then we can multiply 10 to the 4 times 10 to the 6, and we just add the exponents and get 10 to the 10. The only problem here is we just created a number that's not between 1 and 10. So if that happens, we have to change that number to 2.4, and we add 1 to the exponent, 10 to the 11. Because instead of moving the decimal 10 spaces to the right here, we have to move it 11 spaces from here to get the same number. Okay? So that's how we multiply scientific numbers. Division, pretty much the same thing. We're going to take the number part of it and divide that. 3 divided by 6 is 0.5. And then what are we going to do with the exponents? We're going to subtract them because it's a division. Okay. Now again, it's not a number between 1 and 10, so this time I'm going to move the decimal to the right 1, so it's going to become 5 times 10 to the 1. We subtract 1 from the exponent. And that's going to give me the same number. If I move this decimal 2 spots over, that's 50. Same as if I move it 1 spot over here, it's 50. Okay. So that is section 5.1.